Hey, Eli. How are you?
Good.
Good. I guess I'll start with the homework unless you had any other questions on the classwork.
No, ma'am, you can start on the homework.
Okay. All right. So to solve by elimination, what you want to do is look for the equation that has the same coefficient. And so on this first one, that's going to be our y because they both share a common coefficient of 1. When there's no coefficient written, we understand that to be 1. And then the second thing that I said to do is to look for the sign that precedes it. And if there's no sign written, once again, we assume that sign to be a positive. So in this case, we'll eliminate the y variable by if the coefficients are the same and the signs are the same, we use subtraction. So we'll subtract the bottom equation from the top. So y minus y, it leaves us with a 0. And then a minus x minus a 4x is going to give us a negative 5x. And then a 1 minus a minus 14. That's going to change that second minus to a plus. So that's going to give us 15. So now what I want to do, kind of like we did in class yesterday, you want to have the variable on one side and the constant on the other. So I'm going to add 5x to both sides. And now I have just a plain old linear equation. I'm going to divide both sides by 5. And I have x equals 3. Now I'll go back to substitution. And I'm going to take that value of x and plug it in. Not forgetting that negative because there's a negative there, or an opposite sign, if you will. And now I have minus 3 plus 1. So that's going to be a negative 2. So if I were to graph these two equations on a graph, the point at which they would intersect is going to be 3, negative 2. Any questions about that?
No, ma'am.
Okay. All right, on number 2, once again, looking at identifying both of those equations, looking for something with a common coefficient. It's going to be our y. They both have a coefficient of 1, and the signs are positive, so they're matching signs, so we will subtract. When the signs are the same, we subtract. So y minus y is 0. And then negative 3x minus a minus 8x. That's going to change that minus to a plus. So I've really got negative 3x plus 8x. So that's going to give me 5x. And then I have 5 minus a minus 25, which that's going to then give me a negative 20. So I'm going to subtract 5x from both sides so that I can have a variable on one side of the equation and a constant on the other. And once again, yesterday on her example problem, she moved the constant. You are welcome to do that. But just like I told you guys in class, If I have a choice, and I do here, I prefer my variable to be on the left. So now I have a regular linear equation, which I can divide both sides by -5. And that's going to give me x equals 4. So I'll go back to substitution and I'll substitute the value 4 into one of the equations. It doesn't matter which one. I typically pick the one with the lowest number so that I'm not working with large numbers. And that happens to be the one on the top here. So y equals -3 times 4. Because I'm substituting that value x in for the x plus 5. That's going to be -12 plus 5. It's going to be -7. So y equals -7. So if I were to graph these two equations, the place at which they would intersect is going to be 4, -7. All right, number 3. We're looking for the equation or the variable or term, there we go, Miss Sparks, that has the matching coefficient. On number 3, that's going to be x. Once again, when there's no coefficient there, it's an understood 1. And then the next thing that you look for is what is the sign that precedes the matching coefficient. And when there's no sign there, it's also understood to be positive. So that's a +1 on the top equation and a +1 on that second equation. So since it's matching signs, we subtract. So we have x minus x, which is 0. And then -2y minus 3y is going to be a -5y. And 10 minus 5 is 5. So we really have -5y equals 5. We'll divide both sides by -5. And we have y equals -1. So we'll then take that value and substitute it back into one of the two equations. Once again, it does not matter which equation you pick. I'm going to choose the first one in this. We've got x minus 2. Substitute the value -1 in for the y. And then solve for x. So I've got x, and then -2 times -1 is a +2. And now I'll subtract 2 from both sides of the equation to isolate the variable x. And I have x equals 8. So if I were to graph these two equations on a graph, they would intersect at the point 8, -1. So that ordered pair is the solution to this system of equations. All right, number 4. The matching coefficient is what in this one? Anybody tell me?
-3.
-3, good job. And it's -3 in the top one and -3 in the bottom one. So the signs are the same, so we will subtract. So 2x minus a -5x. So that turns that to a positive, so that's actually going to be 7x. And the -3y minus a -3y, that turns that to a positive, but they cancel out. That was our whole goal. And then 9 minus 30 is going to be a -21. So we'll divide both sides by 7. and we get x equals -3. So now we'll take that value, -3, and substitute it back into one of the two equations. Doesn't matter which one. But we substitute it in for the x. And then we can solve for the y. 2 times -3 is -6. Add 6 to both sides. We have -3y equals 15. Now you divide both sides by -3, and you get y equals -5. So if we were to graph these two equations on a graph, the point at which they would intersect is -3, -5. So the solution to this system of equations is -3, -5. All right, on number 5, they actually both have coefficients that match. The x both have ones in front of them, as do the y's. But in this particular case, the y's are opposite of each other. So I'm going to pick that to show you that when the signs preceding the coefficient are opposite, you add. So that's why I'm going to do that here. Because they're opposite, you've got a positive on the y in the first equation and a negative or a minus sign on the y in the second equation. So x plus x is going to be 2x. And then a positive y with a negative y gets me 0. So I've eliminated it. And now I have a -4 combined with a +2, which is going to give me a -2. Divide both sides by 2. And I have x equals -1. Now I will substitute that -1 back into either equation is just fine. I'm just going to pick the top one. It wouldn't matter which one you picked. You're still going to come out with the same answer. We're going to add 1 to both sides. And we have y equals -3. So if I were to graph these two equations, the point at which they would intersect on the graph is -1, -3. So that is the solution to this system of equations. Number 6, the matching coefficients on this one is 3, and it's on the y. The term with the matching coefficient. Now we check the signs that precede the matching coefficients, and we see one is negative and one is positive. So when the signs are opposite, you add. So I have 2x plus an x, that's 3x. And then -3y plus 3y, that can't love you. Have a good day. Be careful. That cancels each other out. So we have 14 plus -11. So that's going to give me 3. So now I have a simple linear equation. Divide both sides by 3. X equals 1. So now I'll take that value, x equals 1, and I'll substitute it back in to one of the two equations. And I'm actually going to pick the second one. 1 plus 3y. It doesn't matter which one you pick, though. If you would have picked the top, you're still going to get the same answer. Subtract 1 from both sides. So I have 3y equals negative 12. Divide both sides by 3. And y equals negative 4. So the solution to this system of equations is 1, negative 4. So if I were to graph them, that would be the place at which they would intersect on the graph. Any questions so far? Okay, number 7. Which one, what is the matching coefficients? Maybe that's a better way to ask it. What is the matching? 3. Good job, Eli. All over it. Are the signs the same or are they opposite?
Opposite.
Opposite. Good job. Way to go, guys. Okay, if the signs are opposite, how are we going to combine the two equations? Are we going to add them or subtract them?
Add them.
Good job. Way to go, guys. Y'all are getting this. I'm so proud of you. Okay, good teamwork. So negative 3x plus 3x, that cancels those out. Then negative 4y plus minus 1y, that's going to give me a negative 5y equals negative 1 plus a negative 4 is going to be negative 5. Divide both sides by negative 5. And y equals 1. Now we'll substitute the value 1 back into one of the equations. I'm just going to pick the second one again because I'll usually pick the first, but I'm going to pick the second one this time. Just to kind of show you guys, it doesn't matter which one you pick. It's going to work either way. I usually try to pick the one with the simplest, but none of these numbers are really ginormous or anything. So 3x equals negative 3. Divide both sides by 3. And x equals negative 1. So if I were to graph these two equations, the point at which they would intersect is negative 1, 1. So the solution to this system of equations is negative 1, 1. Okay, on number 8, what is the term with the matching coefficients?
The 6x.
Yes, good job, guys. The 6x. Are the signs the same or are they different?
They're the same, so you're going to subtract?
Yes, they're the same, so you're going to subtract. Good job. Both of you were chiming in. Good job. I'm so glad that y'all are getting this. So 6x minus 6x. So that eliminates those two. And then 5y minus a minus 7y. So that's going to change that to addition. So that's going to be 12y equals, and then 4 minus a minus 20. So that's going to change that to addition as well. So that's going to be 24. Divide both sides by 12. And y equals 2. So now I will substitute that value 2 back into one of the equations. So 6x plus 5 times 2, because I'm substituting the value 2 in for the y, equals 4. So 6x plus 10 equals 4. Subtract 10 from both sides. I have 6x equals negative 6. Divide both sides by 6. and x equals -1. So if I were to graph these two equations, the point at which they would intersect is -1, 2.
Miss Sparks,
Yes.
Annie asked if you could do 12, 14, and 16.
Absolutely. Thank you for chiming in to let me know. I absolutely will do that. So 12, 12, 14, and 16. Did I get those right?
Yeah.
Okay. Absolutely. Okay. Now, when the equation isn't in standard form, like number 12, Finn, no. It's just Mr. Eric. Stop. Shh. Sorry, guys. You want to change them into standard form. So because you want your terms to line up. All right. So the first one is in standard form, but the second one is not in standard form. So I'm going to change that one into standard form. So this is my side work here. So I'm going to subtract 7x from both sides. So now I have -7x plus y equals 67. And then I'm going to take this first equation and I'm going to line it up underneath the other equation. And now those will be the two that I'm going to work with because my -7x is lined up with my 2x. My y's are lined up and my constants are lined up. And the y is the one with the matching coefficient because it's an understood one. The signs are opposite. And when the signs are opposite, I'm going to add this system of equations. So I've got -7x plus 2x. So that's going to give me a -5x. My y's cancel, which was the goal. And then I've got 67 plus a -22. So that's going to give me 45. I'm going to divide both sides by -5. And that's going to give me x equals -9. I'll take that value, -9, and substitute it back into one of the equations. Y equals 7 times -9 plus 67. It wouldn't matter which one you plugged it into. So if you guys would rather have done the first one, you sure could. 7 times -9 is -63 plus 67. So that's going to give me y equals 4. So if I were to graph these two equations, the point at which they would intersect is -9, 4, and that is the solution to this system of equations. And I think the next one she asked for was 14. Hold on, let's see if I can. All right, once again, these are not both in standard form. So I want to get them into standard form in order to line up my terms. So I'm going to take that first equation and get it in standard form. And I'm going to add x to both sides. X plus 4y equals -3. Then I'm going to bring down that second equation. I've got 7x minus 4y equals 43. I noticed that my 4's My y term is the one with the matching coefficients, both of them having the number 4. Then the next thing I want to look at is what is the sign that precedes the matching coefficient. One is plus, one is minus. They are opposite, so I will add. X plus 7x is 8x. The 4 y's will cancel. And then negative 3 plus 43 is 40. Divide both sides by 8. And I get x equals 5. Then I'll take that x value of 5 and substitute it back into one of the two equations. Once again, it doesn't matter which one. Just always be cautious when you're plugging things back in to watch your signs. Minus 3 minus 5, because there's a minus, and this would be in parentheses, but that just turns it to a negative 5. So I have 4y equals negative 8. Divide both sides by 4. And y equals negative 2. So the solution to this system of equations is 5, negative 2. That means if I were to graph these two lines, that is the point, 5, negative 2, where they would intersect. Now, number 16. They're not in standard form, so I want to take this second equation and I want to get it in standard form in order to line up my terms so that I can combine them. So I'm going to add 9x to both sides. So now I have 9x plus y equals negative 26. Now I'm going to take this first equation, negative 2x minus y equals 12. And you can see that all my terms line up. And the term that's matching with the matching coefficient is the y. There's an understood 1 before each of those. So then the next thing I'm going to do is look at the signs that precede the matching coefficient. One is a plus, one is a minus. So that means the signs are opposite. So I'm going to add that second equation. So 9x plus a negative 2x gives me a 7x. The y's cancel. Negative 26 plus 12 is going to give me a negative 14. So I'm going to divide both sides by 7. And that gives me x equals negative 2. So now I'm going to take that value, negative 2, plug it back into one of the two equations. It doesn't really matter which one.
And as far as if the signs are the same, then you subtract. And if they're opposites, then you add, right?
Correct.
Okay.
Good clarification question. Yes, that is true. So negative 9 times negative 2 is a positive 18. Negative 26 combined with a positive 18 is a negative, whoops, sorry about that, guys, negative 8. So the solution to this system of equations is negative 2, negative 8. Thank you for asking specific questions. That leaves y'all about 5 to do on your own.
Could you do 13 and 15?
13 and 15. Yes. I do want to try to get to also the. How many of you have had a chance to watch the video yet? Or are you just working on this so far?
I did.
Okay. I wanted to try to get to the two things I wanted to get to today in Math Lab, but I'll definitely do those. But I wanted to get to the guided practice problems, and I also wanted to continue on that graphing review. Or maybe, I wonder if I should save that for Tuesday. I don't know. I'm kind of praying about it, but 13 and 15. Okay. 13, one of the two equations is not in standard form, so I need to get it in standard form. That's the second equation is not in standard form, so what we have to do to get it there is to subtract 3y from both sides. That way it'll put our x and our y's on the same side. So we have 4x minus 3y equals -9. Now we'll take that top equation and line it up underneath our second equation. Lining up our terms, our x terms, our y terms, and our constants. We want to identify the matching coefficient. So that's going to be the 3 on the y term. Then we want to identify the sign preceding the matching coefficient. In this case, they're both negative. When the signs are the same, you subtract. So 4x minus 6x is -2x. -3y minus a -3y, that changes that to a plus, and they cancel or eliminate, which was our goal. And then -9 minus a -21, that changes that to a plus. So we really have 21 minus 9, which is which is 12. So we're going to divide both sides by -2. And that gives me x equals -6. And now we'll substitute that value, -6, back in for x. So 4 times -6 equals 3y minus 9. So -24 equals 3y minus 9. And add 9 to both sides. And that's going to give me a -15 equals 3y. Divide both sides by 3. -5 equals y. So the solution to this system of equations is -6, -5. That would tell me where the two lines would intersect if I were graphing them. All right, number 15. Once again, they're not both in standard form, and we want to get them there. So we'll take that second equation and get it in standard form. We have to add 6y to both sides. And now we can take that top equation and line it up underneath the second equation, lining up our terms. The term with the matching coefficient is the x term because there's an assumed 1 on both of them. The signs are the same, so we will subtract. X minus x, that eliminates the x's. 6y minus 3y is 3y. And 14 minus 5 is 9. divide both sides by 3, y equals 3. Now we'll take that value 3, plug it back in to one of our equations. Doesn't matter which one. So if you picked a different one, you should be fine. Negative 18 plus 14 is a negative 4. So the solution to this system of equations is negative 4, 3. Now y'all only have 3 to do all on your own. I'm going to do the solve linear system using elimination guided practice problems. I need to pull up. Oh, yay. There's lots of stuff on this. Did the practice with the elimination problems, did that help today to clarify things for you guys?
Yes.
Good. I'm glad to hear that. So, do y'all still like elimination better than substitution, or do you like substitution better than elimination?
Substitution.
Yeah. Anybody like graphing better?
I like elimination.
Oh, good. Yeah. Yeah, it's the good thing about this stuff is there are multiple ways. Do I have any people that actually like graphing best? Nobody chiming in on that one. I don't even think Miss Sparks likes graphing better than elimination or substitution. I'd take either one over there. I don't mind graphing, but
Miss Sparks, can you do number 1 on page 394?
I'm going to do, I thought I was going to do all of them, actually.
Okay.
But yes, most definitely, darling, I will do that. I forgot to, oh, no, yeah, I forgot to pull the book up on my other computer, so I'm trying to quickly read the, problem, and then 6x minus 2y equals 1. Normally I have the book pulled up on my other computer. so I can read the problem. Oh, my least favorite thing. I know why it was a wee bit of a struggle for you guys. It's a decimal or a fraction in this one, and I normally wouldn't do that to you guys. Not when I'm trying to teach a concept. I do think fractions are great when you've nailed a concept, but teaching the concept, I wouldn't have done that. And I also didn't set myself up very good. I have to start over. On this one, you need to kind of leave yourself some room out front for your multiplying. So my apologies. What you're trying to do with this type of system of equation with elimination is you want to look at the coefficients that have similar multiples. So what you would do in this case is that I know that 2 can go into 6. Okay? So that's going to be the one that I pick, because that means I'm only going to have to multiply one of the 2 equations. Sometimes you actually have to multiply both. But in this case, I know that 2 will go into 6. So what I'm going to do is multiply this second equation, the whole thing, because I can't multiply just one thing. I have to multiply the whole thing. I'm going to multiply the whole thing by 3. Remember, we did some of this in an earlier chapter, because it doesn't change the equation, just changes the look of it. It doesn't change the value of it, though. So 3 times negative 2 is negative 6x. 3 times 3y is 9y. And 3 times a negative 15, or negative 5 is negative 15. So now I've got it to where my coefficients are matching. My 6 and my 6 are now matching. My x terms are matching. And I'll look at the preceding sign, and they're opposite. So that means I'm going to add the 2 equations. So I have a 6x and a negative 6x. That eliminates those. Negative 2 and a plus a positive 9 is going to give me a 7y. And 1 combined with a negative 15 is going to be a negative 14. Divide both sides by 7, and y equals negative 2. So now I will substitute that value, negative 2, in for the y in either equation. It doesn't matter. So 6x minus 2 times negative 2 equals 1. 6x plus 4 equals 1. Subtract 4 from both sides, and that gives me 6x equals negative 3. Divide both sides by 6, and x equals negative 1/2, or negative 0.5. So the solution to this system of equations is negative 1/2, negative 2. Not my favorite thing when they are introducing a concept and throw a decimal or a fraction on you guys. Still works. I like it better after we've nailed a concept, though. I like them to stick with plain old integers. All right, number 2. 2x plus 5y equals 3. 3x plus 10y equals -3. All right, our terms are all lined up. That's good. The next thing we want to look at is there terms that are multiples of each other? And there, in fact, is the y. 5y is a multiple of 10y because I could multiply 5 by 2 to get to 10. So that means I can multiply that top equation, everything by 2, in order to be able to eliminate them. So 2, or to eliminate the y term. 2 times 2x is 4x. 2 times 5y is 10y. And 2 times 3 is 6. So I'm going to rewrite this second equation. And now my y term is matching. The coefficients are, so 10y and 10y. The sign that precedes the matching coefficient, both are positive. So that means I'm going to subtract. Same signs, subtract. 4x minus 3x is x. 10y minus 10y, those cancel. That was our goal. 6 minus a minus 3, that turns into a plus. So that's going to be 9. So x equals 9. Now I'll take that value and substitute it back in to one of the two equations. Doesn't matter which one. 2 times 9 plus 5y equals 3. 2 times 9 is 18 plus 5y equals 3. Subtract 18 from both sides. 5y equals -15. Divide both sides by 5. And y equals -3. So the solution to this system of equations is 9, -3. So basically, this is the same as the last elimination. It's just that you have to manipulate the equation a little bit in order to get them to match. So you're multiplying each equation by something in order to force the terms to match. And as long as you remember to multiply everything so that you don't change the value of the equation, that's really, really important too. So the last one. And this is going to be interesting because it's not in standard form. So we'll have to fix that. And then on top of that, I think we're going to have to multiply both of them if I'm remembering correctly. So we have 3x minus 7y equals 5. And then we have 9y equals 5x plus 5. So they're not both in standard form, so that's one of the first things that we've got to do is change this second equation into standard form. So I'll subtract 5x from both sides. And now I have negative 5x plus 9y equals 5. I'm going to rewrite that top equation underneath here where my terms are at least lined up. And I look at this and I think, wow, neither one are really multiples of each other within the same family. I mean, obviously I see that 3 and 9 are multiples of each other, but that's not going to cancel those terms, those matching terms out. So in this case, you're going to have to multiply both equations by something to eliminate them. And you want the least common multiple because you don't want those numbers to get really, really big. So I'm probably not going to pick the 9 and the 7 because that's going to get me, into 63. So I'm going to work with that 5 and 3 on the x term. So what I'm going to do there is I'm going to multiply the top one by 3. Didn't leave myself a lot of room to write that, did I? And that bottom one by 5. So 3, because then if I multiply that top one, I'm going to have a negative 15x in the x term, and I multiply that bottom one by 5, I'm going to have a positive 15x. So then I know I can really eliminate them. So 3 times negative 5x is negative 15x. 3 times 9 is 27y. And 3 times 5 is 15. Now this next one, 5 times 3x is a positive 15x. 5 times negative 7 is negative 35y. And 5 times 5 is 25. Got to remember to multiply the whole equation by that, by the multiplier. And what the whole goal was is to get 2 of the terms so that they're matching. And we have matching coefficients now on the x. We have 15 and 15. The signs preceding them are opposite. So that means we're going to add the equations together. So the 15s cancel out. And 27 combined with the negative 35 is negative 8y. And then 15 plus 25 is 40. Divide both sides by negative 8. And we have y equals negative 5. Now I take that value and substitute it back in to one of the 2 equations. It doesn't make any difference which one. I'm going to actually pick the second one. 9 times negative 5 equals 5x plus 5. 9 times negative 5 is negative 45. Subtract 5 from both sides. That's going to give me a negative 50 equals 5x. Divide both sides by 5. And my answer is negative 10 equals x. So the solution to this system of equations is negative 10, negative 5. So if I were to graph these two lines, that would be the point at which they would intersect. Any questions about that third example?
If you wanted to check your answer, could you just put the solution back into the original equation?
You absolutely could. Great question. Great question. And they may have done that in the video, did they?
Yeah, I think they did.
Yeah. Yeah, you definitely could do that. And it should work in both equations. The statement should be true. Did you want me to do it?
Yes, please.
Okay. All right. So what we're doing is plugging in. My solution was what? Negative 10, negative 5. Is that correct? Is that what I said?
Yes.
Oh, so long ago. All right. Well, let me make some room for myself. But yes, you could definitely check it. And both statements should turn out to be a true statement. Does that make sense?
Mm-hmm.
Okay. So if you get an untrue statement, there's a possibility that you did something wrong along the way. Okay, so we'll plug in that first equation there, 3 times negative 10 minus 7 times negative 5 equals 5. Negative 30, negative 7 times a negative 5 is a positive 35. Negative 30 plus 35 is 5 equals 5. So that's true and that one checks. 9 times negative 5 equals 5 times negative 10 plus 5. 9 times negative 5 is negative 45. 5 times negative 10 is negative 50 plus 5. Negative 45 equals negative 45. And that one checks.
Okay. Thank you.
You're welcome. Any other great question? Any other questions? Because that just shows that it, how you can, join, how you can check and make sure that you're right. Any questions?
No, ma'am.
Okay. Would you all like me to do the graphing review, or would you need to move on to other homework and prefer me to wait for next Tuesday's math lab?
Can you wait till next Tuesday?
Yes, ma'am. Can you wait?
Oh, absolutely. Because I know that y'all have a lot on your plate. So, and we're going to be doing a lot of graphing and reviewing of graphing in class next week and even the following Monday.
Okay.
Okay.
Thank you.
All right. Well, y'all have a blessed afternoon. Love you guys. Take care. Bye-bye.